Hi, I am T. Kavitha, Assistant Professor, Department of Mathematics. Today I am going to explain the topic of correlation. Correlation. The word correlation is used in everyday life to denote some form of association. We might say that we have noticed a correlation between foggy days and attacks of busyness. However, in statistical terms, we use correlation to denote association between two quantitative variables. We also assume that the association is linear, that one variable increase or decreases a fixed amount for a unit, decrease or decrease in the other. The other technique that is often used in these circumstances is regression, which involves estimating the best straight line to summarize the association. Correlation coefficient. The degree of association is measured by a correlation coefficient denoted by gamma or R. It is sometimes called Pearson's correlation coefficient after its originator and is a measure of linear association. If a curved line is needed to express the relationship, other and more complicated measures of the correlation must be used. The correlation coefficient is measured on a scale that varies from +1 through 0 to -1. Complete correlation between two variables is expressed by either +1 or -1. When one variable increases as the other increases, the correlation is positive. When one decreases as the other increases, it's negative. Types of correlation. The scatter plot explains the correlation between the two attributes or variables. It represents how closely the variables are connected. There can be three such situations to see the relations between the two variables. That is, first one is positive correlation, when the values of two variables move in the same direction so that the increase or decrease in the value of one variable is followed by an increase or decrease in the value of the other variable. That is called positive correlation. Here I give the diagram for strong positive correlation. It explains the positive correlation. Next one, negative correlation. Here, when the values of two variables move in the opposite direction so that an increase or decrease in the value of one variable is followed by decrease or increase in the value of other variable. That is called negative correlation. Here I give the diagram for strong negative correlation. Next one, no correlation. When there is no linear dependence or no relation between the two variables. There is no relation between two variables is called the no correlation. And correlation coefficient formula. The simplified correlation coefficient formula is denoted by here, that is R is equal to n into summation of xy minus summation of x into summation of y divided by root of n into summation of x square minus summation x the whole square n summation of y square minus summation of y the whole square. This is the simplified formula for correlation coefficient. Now I give the one problem to explain this formula. Calculate the correlation coefficient between x and y and comment on their relationship. Here the data is x is equal x 2, 6, 8, 10, 14 and 16 and y is 4, 12, 16, 20, 28 and 32. Now we use the correlation coefficient formula called Pearson coefficient of correlation is n into summation of xy minus summation of x summation of y divided by root of n summation of x square minus summation of x the whole square into root of n into summation of y square minus summation of y the whole square. First we did the table for this data. The given x and y, we take the summation for x is 56 and summation of y is 112, and we can calculate xy, the multiplication of x and y, and sum of xy is 1312, and we find x square, and summation of x square is equal to 656, and y square, summation of y square is equal to 2624. Now we substitute these values to the formula. 6 into 1312 minus 56 into 112 divided by root of 6 into 656 minus 56 whole square, root of 6 into 2624 minus 1254, 544. We get the formula 1.0001. The gamma value is 1.001, that is equal to 1. Okay, therefore the correlation coefficient between x and y is perfect positive correlation. Thank you.